Yeah, of course. System administration is actually where I learned how systems actually behave, not just in theory, but in real environments. You see how operating systems, networks, and applications interact under pressure, how things fail, and what working really means in production. And at some point, that naturally sparked a different kind of curiosity in me. So instead of just operating systems, I became genuinely interested in building them, understanding how these different components are designed in the first place and how they could be improved. During my university years, we even founded an open source group called Ender Unix. That was an important phase for me because we were really solving real problems for real people and sharing the results openly. And that platform allowed me to experiment with building tools that have been deployed and used by tens of thousands of people around the world. And of course, over time, I wanted to take that same mindset and apply it to more complex, higher stakes environments. Like, for instance, businesses have very different requirements, of course, like scale, reliability, security, and accountability. And today, my focus is shaped by that entire journey. I care a lot about how systems behave in general, in real world, and how they are deployed, how they perform under load, and how easy they are to operate. Security in particular only works if it is easy, it fits naturally into the environment it's protecting. Otherwise, it becomes a friction point instead of providing protection, which is very important. I usually start with a simple observation, right? Most security stacks today are integrations, they're not architectures. Over time, the industry has assembled solutions where different engines and often entirely different products handle pieces of the same problem. That creates overhead in performance, coordination, management, and reliability. So I break it down to three ideas. Single pass is about how traffic is processed. You inspect traffic once in a unified flow with full context. You're not reprocessing the same packets across multiple engines and over again trying to reconcile fragmented decisions. That improves both performance and consistency. Single stack is about how the system is built. Instead of loosely connected modules, everything is designed as a one coherent architecture. That reduces resource usage, avoids synchronization issues, and eliminates many of the edge cases that come from different components interpreting traffic differently. And then there is the single app, which is what operators actually deal with. With all your enterprise network security fitted in a single application, you start to enjoy an unprecedented level of agility. Because of that, single app can just attach to any networked environment and can start delivering security immediately. That has huge impact on deployment speed, operational simplicity, and overall usability, right? So what I emphasize is that these aren't just optimizations. When you combine them, you move from a collection of parts to something that behaves as a unified whole. And in security, consistency, performance, and agility is very important for today's modern organizations who are more distributed, agile, and flexible than ever before. On paper, it looks very straightforward. You define a policy centrally, distributed everywhere, and you're done. But in reality, distributed environments are full of inconsistencies. Devices are in different networks, latencies are different, some nodes are temporarily offline, users move between networks and locations constantly. So the real challenge is not distributing the policy, it's ensuring that the enforcement outcome is consistent. And another important issue is the hyper-distributed nature of the modern organizations. Traditionally, policies were enforced when users were inside the corporate network, where you had full visibility and control. But today, users spend a significant amount of time off network, working from home, on mobile connections, or directly accessing cloud applications. That creates a fundamental inconsistency. So on-network traffic is inspected and enforced one way, Off network traffic is often handled very differently or not handled at all. So the real difficulty is not distributing policies, but ensuring that the same policy produces the same outcome regardless of whether the user is on network or off network. And that's much harder than it sounds. The biggest thing I had to unlearn, I guess, was trusting the perimeter. Back in 2000s, a solid firewall meant you were doing most of the network security. That assumption collapsed long before AI, but AI has made it worse because now attackers can probe, enumerate, and find gaps at machine speed with no fatigue. I also had to unlearn that attackers would be noisy. Modern adversaries want really quiet persistence. And now AI generated phishing and deepfake social engineering means the human detection layer, which we fell back on when technical controls failed, is also getting eroded. The through line is that slow, unsophisticated, human speed adversary is gone. The modern attacker is faster, more convincing, and more scalable than anything back in 2005.